In this section, we'll give you a high-level overview of the Corda blockchain platform. You'll see that Corda, in order to meet the requirements of businesses, differs in a number of ways from traditional blockchain platforms. Once we start building our Corda app in the subsequent sections, this overview will serve as a useful framework for understanding how the various parts of your Corda app fit together. To understand Corda, we first need to understand how traditional blockchain networks are structured. In traditional blockchain networks, each node on the network is identified solely by a pseudonymous public key, rather than having a recognizable identity. And messaging between these identities is unencrypted, and it occurs using something called a gossip protocol, which distributes every message to everyone. And clearly, this doesn't meet the needs of real businesses. So when real businesses strike legal agreements, they need to strike these agreements with legally identifiable counterparties, and not just with pseudonymous public keys. And equally, real businesses need to keep the details of their transactions private from third parties. This is strongly desirable for strategic, but also often legal reasons. And so, to meet the needs of businesses, Corda networks are architected differently. So before joining the network, each node undergoes a KYC process to obtain an identity certificate. And then when they join the network, they publish this certificate, including their legal name, their IP address, their public key, as well as some other information, to a network map service. And then nodes can use this network map service to transact with well-known counterparties on the network using private point-to-point TLS encrypted messaging. So here on our slide, we have a network of 3 nodes and a notary pool. In a real Corda network, we'd have many more. And taking one of these nodes as an example, we can see that the Titan Technology Partners node at the bottom, well, it has a legal name of Titan Technology Partners. It's contactable at the address 115.187.2840 on port 10,005. And it has the root public key 5HW03, etc. And all this information means that when Titan Technology Partners transacts, all their messages are encrypted and only sent to specific, legally identified counterparties. Now, one obvious question is, if data is only distributed on the network on a need-to-know basis, how do we prevent double spends? How do we prevent some node transferring some digital asset to one party and then turning around and also transferring it to another party? In Corda, we prevent double spends using notary pools. A notary pool is a set of nodes, generally a set of mutually distrusting nodes operating a Byzantine fault-tolerant consensus algorithm, that will only sign a transaction if it does not represent a double spend attempt. Every transaction requires a signature from a notary to be valid. And the nodes in the notary pool do not actually see the contents of ledger updates. They only see the hash of each transaction updating the ledger and the index of the fact being consumed in the outputs of that transaction. What are these nodes that sit on the network? We can think of Corda nodes as magic blockchain boxes. They provide these user-defined flows that allow the node to perform some action, usually to update the ledger, with a single click. And they also provide the ability to read back data from the ledger to see the results of executing these flows. And the advantage of the node is that all the horrors of distributed systems, cryptography, and data management are completely hidden from the user. So you don't have to worry about messaging or about storage or about peer discovery, data distribution, concurrency, disaster recovery, signing. All of that is abstracted away by the node software. For their node to be useful, a node operator will want to install one or more flows on their node. And these flows describe a sequence of actions for the node to perform. So here in the diagram, we have an example flow where one node, node A, is attempting to perform a transaction to update the ledger. So we start by telling node A to create, verify, and sign a transaction, and then to send it on to another node, node B. The flow then tells node B to verify and sign the transaction it receives before sending it back to node A. It then tells node A to send the transaction onto the notary pool. It tells the notary pool to sign the transaction before sending it back to node A. The flow then tells node A to record the transaction and send it to node B. And finally, the flow tells node B to record the transaction. And this is only an example of a flow. The flow framework is completely flexible. You could write a flow that doesn't speak to any other nodes, or a flow that doesn't update the ledger at all, or a flow that does database operations or HTTP calls. It's completely up to you as the Corda app developer. In summary, we have seen how Corda is a unique blockchain platform designed to meet the requirements of businesses. It allows private transactions between parties. It allows these parties to identify exactly who they're transacting with. And it does so while abstracting away the complexity of distributed solutions. So that's the end of this section. In the next video, we'll start getting our machines set up for Corda app development.